So, you want to get into data science, but you're not sure where to start with Python? Well, you're in the right place. Python is the go-to programming language for data science, powering everything from financial forecasting to medical research. Why? Because it's easy to learn, has powerful libraries, and is used by top companies worldwide. In this crash course, we're skipping the Hello World basics and diving straight into the real Python skills you need for data science. By the end of this video, you'll be able to load and manipulate real-world datasets, perform data cleaning and transformation, visualize patterns in data, and write efficient, data-focused Python code. Here we are taking a dataset of people who were on board in the Titanic ship for all the example and hands-on explanation. Link to this dataset is given in the description below. We'll be coding in Jupyter Notebook, which is widely used for data science and makes it easy to write and run Python code. So, grab your notebook, follow along, and let's start coding. Before we do anything, we need to import the key Python libraries that are essential for data science. One of these libraries is pandas. It allows us to work with structured data like CSV files and databases, similar to working with spreadsheets. Next is NumPy. This provides fast mathematical functions and array handling. Then next important library is Matplotlib.pyplot. This helps in creating plots and charts to visualize data. Then there is Seaborn. It makes data visualization easier by offering better-looking plots. Now these are just few libraries, which we walked you through. There are others as well, which we will discuss when they are needed. Now after importing library, let's load a real data set using pandas. So for that we use pd.readcsv. This is used to read CSV file, which is comma-separated values file, which is one of the most common formats for data sets. You can use Excel and other file format as well. Then in the parenthesis we add the path or the link, which contains the data. Now to quickly view our data, we use df.head then parenthesis. This will return top 5 rows in the data, and if you want to see more top rows, so for that you just need to add number of rows you want to see in between the parenthesis. Each row represents a passenger, and each column represents a feature. Now every real-world data is rarely perfect, so we will move to check for missing values. For this we use isNull function and sum function to find the null values and have a total count of how many null values we have. So here the age column has 177 missing values, meaning some passengers' ages were not recorded. This missing data can lead to errors in analysis, so we need to handle it. Since we have found the null values, so we need to replace it with some values to use it for analysis. So we can replace missing values with the median age, using the median function as shown. Here we use fill_NA, then in parenthesis the value. This replaces missing values with the calculated median value. And the in_place equal to true applies the changes directly to DFS instead of creating a new copy. Now that our data is clean, let's visualize how many passengers survived versus how many did not. For this we will use a bar chart. Here we will write sns.countplot. This creates a bar chart showing the count of each category in the survived column. Then we will write plt.title. It will add title to the graph. Now run and it's done. Analyze the data and see what all the data is telling you. Now let's see the distribution of passenger ages using a histogram. For this again, we will write sns.histplot. This creates a histogram, which is a bar chart that shows frequency distributions. Here bins is equal to 30. This is used to split the ages into 30 groups. Then KDE equal to true. This adds a smooth density curve to make the distribution clearer. Now that we've cleaned and visualized our data, let's take things a step further and build a simple machine learning model. We'll create a logistic regression model to predict whether a passenger survived based on their age, fare, and gender. First, we will quickly import the required libraries. We will import train test split library, which helps us to split our dataset into training and testing sets. Then logistic regression, which is the machine learning model we will use to make predictions. Next, import accuracy score. This helps us measure how well our model performs. Now let's start converting categorical data into numerical format. Since machine learning models don't understand text data, we need to convert the gender column into numbers. For this, we will use the map function, which will replace male with 0 and female with 1. This allows our model to interpret gender information numerically. Next, we will select features and target variable. X is our feature set, containing sex, age, and fair, which will help predict survival. After this, we will use drop NA to remove any remaining missing values to avoid errors. Then we will use Y as our target variable, which is what we are predicting. The survival status will have 0 as no and 1 as yes. In the next step, we will start splitting the dataset into training and testing sets. The dataset is split into 80% for training and 20% for testing. The model learns from the training set, then we test its performance on the test set. So for this, we will use train test split function on X and Y and keep the test size as 0.2, because we kept 20% of data for testing. Then we will keep random state equal to 42. This is done to get the same split every time you run the code. With this, your results will be reproducible and it makes it easier to debug and compare models. Finally, now we will train the data. For this, we will create a logistic regression model. Then we will use model.fit on xtrain and ytrain. This trains the model using the training dataset. The model finds patterns in the training data to predict survival. Now let's do the fascinating part. Let's make predictions using our ML model. For this, we will use .predict on xtest, which will make survival predictions for the test set. These predictions will be compared with the actual survival values to see how well the model performs. Now test time. In the end, we will evaluate the model's accuracy. We will perform this by using accuracy score function on ytest and predictions. This calculates how accurate our model is. The closer the accuracy score to 1 or 100%, the better our model is at predicting survival. Now in this model, our accuracy is 77%, which is a decent accuracy to have. Now take your time, go back and understand every single step clearly, because this will be the backbone to your journey ahead. And that's a wrap. This all looks so fascinating, right? So in this video, you've learned how to load and clean real-world data, perform powerful data manipulations, visualize trends with graphs, and build a simple machine learning model. Now don't you stop, keep up the learning pace and head over to more data science video on this playlist. Trust us, you will explore new things. And if you found this tutorial helpful, hit like, subscribe, and turn on notification so you never miss an update. See you in the next video. Happy coding!